Okay, welcome to Biotech 212. I hope you had a chance to look over your course shell in Ivy Lawn. So 211, 212 courses are offered back to back, so 212 course will be about the same way as 211. So we'll have a weekly Zoom meeting for the lecture discussions, and then we'll have face-to-face meetings on Wednesday for the labs. Okay, so review over the course shell for more information. So I'll talk about the lecture one first here. Okay, so the lecture one discussion topics are aseptic technique and cell culture technique. Okay, for the first part, before we talk about the aseptic technique, we'll talk about the importance of aseptic technique in the aspects of CGMP, so current good manufacturing practices. Of course, in the CGMP, the quality control and aseptic processing, playing huge roles, right? So we're going to have a review on these contents. Might have been already covered in your previous courses like Biotech 102. If you already have learned about these topics, it'll be a review opportunity for you. But if this course is the first time you are learning about this, then yeah, pay more attention to these topics. Okay, so quality control, another word, it's bioburden control. When you say bioburden, that means the total number of microorganisms associated with a specific item prior to sterilization. What that means is, in your product manufacturing condition, or in your, clean room surface, or whatever the raw materials that you're using, it's the total number of, microorganisms, including prokaryotic cells or some eukaryotic cells as well. Okay, so potentially those are all the sources of contamination. Okay, so those are considered as bioburden. So you need to control the amount of bioburden in your CGMP space, process, personnel, raw material, and everything, right? So how do you do that? You do that by implementing aseptic processing. So when you do that, aseptic means what? It's everything you do. Try not to cause sepsis. Probably you heard that term sepsis before. So sepsis is a medical condition where people will get sick because the infectious agents that come into our body, including like pyrogen, endotoxin, or other, disease-causing infectious, cells as well. So the aseptic means, the condition, and every measures you do, try not to cause sepsis, try to prevent sepsis. Okay, so that's what aseptic means. So doing everything clean on the controlled environment, that's what it means, right? So it could be used as a synonym for sterile as well. So sterile means what? It's complete elimination of bioburden, no contaminating agents. That's what sterile means. So you do everything as much as possible to provide aseptic condition. Okay, that's what you want to do. Okay, so in the industry, number of measured CFU. CFU stands for what? Colony forming units. Basically, one colony is made from a single cell. So that's same as number of cells that are present in your sample. Okay, so the industry number of measured CFU should not exceed the limit required by the FDA. Okay, FDA has a guidance, of course, on what the CGMP space should look like when you do, the swab test. What is the allowed maximum CFUs from your samples? So they have all detailed guidelines for that. So you have to have your facility and process and everything under the control, the maximum guideline provided by the FDA, of course. And bioburden testing of components can show the use of adequate control measures during the preparation and handling, of course. Okay, that's important. So how do you do that? So QC, quality control within quality assurance. So QC is responsible for testing, of course. So by going out to different places, take samples, and then doing some assays and testing experiments to get measures, right? And those values will be compared against the guideline, of course. So So defined as fitness for use, of course, you have to have some numeric values to compare. Of course, that's what it means. Need to be integrated throughout the process, of course. So if you look at this pie chart, so if you want to control your bio button, how do you do that? Okay, it takes every kind of effort. That's what it is basically. What's making this pie chart. Look at the titles. HVAC system, for example, your heating, ventilation, air control system, of course, what air you bring in and how you bring in, how you clean your air. Heating as well, how do you provide a constant temperature by turning on the heat or turning on the air conditioning unit. Okay, those should be important. And the utilities like water, electricity, gas, whatever you use, what's the control over those, how do you make sure that they are very clean. Sanitization, that's a process to clean up, to reduce as much as possible the infectious agents from your raw materials, space and personnel. That's what it is. Raw material, of course, your quality of them and how do you validate them if they are good for your use in your manufacturing. And then adhere and enforce the guidelines and rules. Of course, it's everybody's role. That's important to follow the batch record CGMP guidelines. Housekeeping, of course, who's doing the cleaning of your workspace, work process. There are people coming in and doing the daily routine cleaning process. They should be well trained so they can carry out effective cleaning process. Equipment as well. You need to clean up your equipment and they should be in good condition. And dress and conduct code, when people go in, what they dress up. So we call that aesthetic gowning. Do they know how to do that? And once they get into the clean room, do they know how to behave inside of clean? Not to speak too much, not to lean on anything, not to grab anything with their hand. Okay, all those guidelines. Sterility. When you talk about your product, it should be sterile, meaning there should not be any bioburden in there. How do you do that? Do you sterilize it by running them through autoclave? If you cannot do that, then what else? Other method can you use? Is it filtration or is it gas sterilization? So you have to provide the method of sterilization. And the toxin content and the toxin pyrogen, same thing. They are the main reagent that can cause sepsis. You need to make sure that you don't have a lot of endotoxin in your product and process. Product handling and storage, of course, how your product is being handled and how it's stored under the right condition. That's important. Bioburden testing, of course, QC technician will go out, take their samples and test how much of bioburden do you have in your process and space and wherever. Environmental monitoring, of course, that's kind of same way, when you go out to the space such as clean room, how do you know how much particles floating in there? What are the living particles? What are the non-living particles? So there should be a way of measuring those. Cleaning validation, same way. When people do the housekeeping, how do you know if they cleaned well, efficiently? There should be a validation process, that validates cleaning or sanitization. Pest control. Critter-free environment is important. How do you make sure that no critter will come into your workspace? Product transportation. Once your product is released, how do you transport? Are they, safe, lyophilized, or are they, should they be refrigerated because they're heat sensitive? And all those things are important. So, it takes a lot of different efforts. Another chart showing in the pyramid shape, all these facility-related controls. Okay, take a look at those and how they are maintained. Okay, uniform, gowning, what attire people should wear, and what kind of sanitization process they have to go through. All those things and training requirements, everything. And then bioburden impacting step, cleaning validation process parameters. So about all process-related guideline and product-related guideline, quality control labs, how they take the samples and measure all those things. So it takes a lot of layers of work to minimize the bioburden, of course. Okay, let's talk about the facility, of course. The space where the CGMP process is taking place. It's important that the space should be clean, of course. Mostly, your manufacturing should take place in the clean room environment. Okay, so when you say clean room, what does that mean? Room should be clean. Of course, it's not that, and it's a very controlled space. That's what clean room is, right? So from the beginning of the room design, you have to consider that space should be all sealed up, and only the controlled airflow will be admitted. And when people and materials are brought in, they should be able to do that through a controlled entries. Okay, there should be pressure, air pressure. So when you open the door, air will go out. It's not going to go in. Those kind of controlled entry and exit is all provided in this clean room environment. So this picture shows you inside of a clean room, one of the local companies. You see people gowned up aseptically. There's no skin exposure, of course. It's a full gown, aseptic gowning. And then you see the tile, the floor tile, it's impervious because they do the wiping, the sanitization all the time. And then I don't know if you can see the corner. Corner is not 90-degree angle. It's kind of curved angle, so corner can be easily cleaned as well. And this is called separator. It's a file filling machine. So this clean room environment is already clean, but you need to provide even cleaner environment. That's this filling machine that has its own maybe air controlling system. So inside of that machine is even cleaner than the space where these people are standing. Okay, so we'll talk more about the clean room environment. So what things could be floating in the air? So why do you have to have those clean room? Because yeah, your air has a lot of biobottom. Okay, it has all kinds of particles, non-viable particles, any kind of dust, fiber, whatever, your hair, and it could also have viable particles like bacterial spores or pollens or molds or fungi spores, and those can land on any kind of a growth environment and they can come back to life, so they can be the source of contamination. So these kinds of old things are all floating in your air, so you have to control those. Now, how do you control? If you filter your air, you can trap those and eliminate those. So control by filters and laminar flow. So understand this term, laminar flow. What does that mean? It's the perpendicular flow of air from the ceiling, okay, and then the air is coming down from the top. So air doesn't never go up. So it's a unidirectional flow from the top of your head. So this from the ceiling, and then air is coming down. It's all unidirectional flow, and above your ceiling, of course, there are filters. So by the time when this air is coming down from your ceiling, it's a clean air. Okay, and gowning, of course, people gowned up to prevent the shedding of their contaminants that can be found from your body, of course. So clean room specification, there are 3 different classification systems that are being used in the industry, of course. Federal standards is more of the specific standard only used by the US, United States, the companies in there. It's one of the oldest, I think, 1963. And then since it's the United States, the only country that's using the imperial system, so this standard is based on the imperial system. So it's like square feet, the cubic feet size, space, and those. And then System International Standard is more universal. So it's an international standard that uses matrix system, of course. And then there's a European standard, EU-based standard, which is more commonly used these days. So we'll take a look at those. So this is the federal standard, of course. So it classifies the environment into 1 through about 6 different clean room areas. So 1 being the cleanest, and class 100,000 being the dirtiest. Okay, so what do those class numbers mean? Those numbers mean number of particles. Class 1 environment means, there's only 1 particle within cubic feet space in the clean room. Okay, so it's the cleanest environment. Class 100 is only 100 particles within the same size environment. Class 100,000, yeah, that is that. Okay,